Okay, we are going to move on to talking about the natural base E. This is considered to be Euler's number, and it is approximately equal to 2.7182818 and continues on. There is actually a button on your calculator, and I believe it is blue, and it has like an E and then an exponent of X. So that is the button you are going to want to use whenever you have to figure out answers with the natural base E. So we're just going to do a couple things with this. It's actually similar to what we did last week. So the first thing we're going to do is evaluate the natural exponential function. So the first example is if f of x equals e to the x, if x equals -3. So you're basically just going to put -3 in there for x, and then you're going to use your calculator, and when you pop it up, it'll say e, and then the caret will pop up with a parenthesis, and you're just going to type in -3, and it equals approximately 0.049. Okay, so in the next one, you would do e to the 0.25 plus 2. Well, 2 plus 0.25 is 2.25. So that's what you would put in your calculator, and you end up getting 9.49. So this is very similar to what we did last week when we just had the exponential functions. Okay, the next thing we're going to do is graph. Same exact thing as last week. The transformations are the same. So if you are adding or subtracting in the exponent, you move left or right. And if you have an addition or subtracted on the outside, then you move up or down. Biggest thing is to make a t-chart again. Basically the same thing as what we have been doing. So here is the graph of e to the x. So we want to go ahead and make a t-chart. And you can still use the same numbers as what you used before. So -2, -1, 0, 1, and 2. So if you put -2 in there for x, so you would do e to the -2 and get 0.14. E to the -1, you get 0.37. E to the 0, anything to the 0 power is 1. E to the 1 would be 2.72. And e to the second would be 7.39. So when you go ahead and go and try and graph this, you notice that it kind of is the same look as what it was before. I'll try and graph this as best as possible. And then 0, 1, 1, 2.72, and then 2. So you notice that it has the same characteristics as the exponential functions before. Okay, so the next example, we have 2 times 2e to the 0.5x. So if we make a t-chart, now thinking about order of operations, you want to do the exponent first, then you'll multiply by 2. So you'll probably want to make a 0.5 x column first. Then you're going to want to multiply that by 2. So remember order of operations whenever you do this. So -2 times 0.5 is -1. So e to the -1 is 0.37. Then 0.5 times -1 would be -0.5. You know what? Here, I'll get rid of this. And that equals 0.61. 0.5 times 0 is 0, so anything to the 0 power is 1. 0.5 times 1 would be 0.5. So that is 1.65, and then 0.5 times 2 would be 1, so you get 2.72. So then you're going to want to multiply that by 2. So 0.37 times 2 would be 0.74. 0.61 times 2 is 1.22. 1 times 2 is 2. 1.65 times 2 is 3.3. And then 2.72 times 2 is 5.44. Okay, so whenever you go to graph this one, you're going to graph, there's your x and there's your y. So it still looks very similar. Then 0, 2, 1, 3, 3, and 2, 5. So you can see this one just isn't as steep as a slope. Okay, next is the one-to-one property, and we did that last week as well. So it's if you have a to the x equals a to the y, then x equals y. So it's the same thing for the natural log exponent. If you have e as being the same, so you have the base of e as being the same, then you can set the exponents equal to each other. And then you're just going to solve this. So if you subtract 2x to each side, 4 minus 2 is 2x. And then subtract the 3. You get 2x equals -9. Divide by 2. And x equals -9 over 2. Okay, so here's the same thing. You've got e to the x squared minus 24 equals e to the 10x. So you can just set your exponents equal to each other. Okay, now when you look at this, you need to actually set this equal to 0. This is a quadratic equation, if you remember that from Algebra 2. So you're going to subtract the 10x over and set it equal to 0. So does anyone remember how to factor? Because that's what you're going to have to do with this. So you have the 2 parentheses, x and x go here, and then you say, what multiplies to -24? Multiplies to -24 but adds to negative 10. So factors of negative 24, you've got negative 6 and 4, 6 and negative 4, negative 8 and 3, 8 and negative 3, 2 and negative 12, negative 2 and 12. So which one of these adds to negative 10? It's this one. So you would have a plus 2 and a minus 12. So now whenever you have these, you have to set each separate one equal to 0, and then you can solve it. So x equals negative 2 and x equals 12. Something to note whenever you have an x squared is you have to have two answers, because the x squared means that it crosses the x-axis twice, so you'll have two answers for those. Okay, and then I think this is the last one. Yeah. So you can set your exponents equal to each other. You're going to want to add the 8 to the other side. Then you're going to need to factor. So what multiplies to 8 and adds to 6? So when you do factors of 8, you've got 2 and 4 and 8 and 1. So which one of those adds to 6? It's this one. So you got plus 2 and plus 4. So you set each separate equation equal to 0. And then you get negative 2 and negative 4. Okay, so basically it's the same thing as last week, but this time we're just dealing with the natural log. So your homework is page 366, numbers 34 to 48 even.